Wiring a receptacle may very well be the first thing you need to do as an apprentice electrician. In this video, we're going to wire up a receptacle in this wall behind me, start to finish, all the way from mounting the box to flipping the breaker. Let's jump in and get it wired. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. The first step is going to be determining where we mount the box. So we're going to be installing this receptacle in this demonstration stud wall. We've actually got an electrical panel here that we're able to fire up and test our work when we're done. And for the ease of filming, we're actually going to be installing this receptacle approximately right here. We're going to measure it out, but we're going to be doing it kind of up a little bit higher. That way I can get the camera in there and show you guys what's going on. For this video, I'm going to choose an arbitrary height of 48 inches above the floor to install this receptacle. So to start out, we need to mark where our receptacle box is going to be installed. To do that, we're going to need our tape measure and a pencil. And in this case, I'm going to be installing this receptacle right here. So I'm going to measure up 48 inches and make a mark. Now the next thing we need to do is actually mount the box on the wall. And the way these work in a wood stud wall is there's nails actually on the box itself. So what we can do is we can set this box against the stud and we can actually pound these nails in. Another neat thing is these boxes actually have these little standoff spacers right here. These little spacers actually tell us how far off the face of the stud to mount the box. So the way we do this is we set it up against the stud and we slide it until those spacers actually come in contact with the face of the stud. This is going to leave just enough of the box sticking out. That way when the sheetrock is installed, the box is actually going to be pushed through the sheetrock. So there is the top of the box marked, and there is the box where it belongs. Now we're just going to take a hammer and we're going to hammer those nails in. Now that our box is mounted, we need to run the wire. And in order to do that, we need to drill some holes through these two studs here to get to our panel. We can't just mount the wire on the face because this is where the drywall is going to hang. So what we're going to do is we're going to drill holes through this stud and this stud to run our wire. So before drilling our holes, we need to consider how we're going to strap our wire once it leaves the box. Now, per NEC requirements, we actually need to strap this NM cable within 12 inches of it leaving the box. And we're gonna use these little straps right here to actually do that. Now that needs to be within 12 inches. Now in reality, we could actually drill the hole anywhere in this wall, and we could route the wire within this cavity to get to those holes. In this case, I want a nice, clean, straight wire run across these studs. So what I'm gonna do is I'm gonna go approximately a foot down from the box, and I'm gonna drill my holes straight across. So a foot from the box is within this area right here. So I'm just gonna arbitrarily take my drill, and about this height right here, I'm gonna drill my holes going this way. Because I'm drilling a small amount of holes, I'm just gonna use a hand drill for this with a 7/8 auger bit. If I was doing this on a large job where I had to drill hundreds of holes, a standard hand drill is not gonna cut it. You're gonna want something called a hole hog, or an even heavier duty drill. The problem is these cordless ones, they overheat if you drill too many holes with them. I've got the drill in first gear and the clutch is set to drill mode. So I'm just gonna take the drill and I'm gonna drill right in the center of this stud right here. As you can see, drilling these holes definitely makes a mess. Now we need another hole in this stud to get up into that cavity to get within the panel. So we're gonna drill another hole right about here. I'm not even gonna bother measuring because my drill will line up approximately with this hole. They don't have to be exactly perfect going through the wall, but they do need to be close. Otherwise, pulling wire gets difficult, especially on longer walls. Before I actually drill this, I wanna show you a problem with this stud. If we take a look at the other side, check this out. There is a ground wire right there. So if I was just to take my drill and start drilling through these studs without checking the back side of them, I could unintentionally nick that ground wire, or worse, that ground wire could actually be in the center of the stud and I could actually grab it and rip it out of the panel with the drill. So when you're drilling through stud walls, it's always a good idea to check the other side, just to make sure you're not gonna be drilling into something that's existing. So I'm gonna go ahead and drill this hole right here as well. These holes definitely do not need to be pretty, but they do need to be free of sharp edges that could grab our wire as we pull it through. So now we've actually got our route from this box through these two studs, and we're gonna be able to get up within this panel. In this case, we're gonna be installing a 15 amp receptacle on a 15 amp circuit. So we're gonna be running 14 gauge wire for this receptacle. This is a 250-foot spool. All I'm gonna do is set this on the ground and start pulling the wire out from the center of the spool. So now I've got enough wire pulled off that I can actually start pulling from the pocket that the panel is in, and I've got enough wire here that I'm gonna be able to pull all the way over to this receptacle. So all I'm gonna do is I'm gonna insert the beginning of the wire into this hole and start pulling it through the wall. Over here at the box, I'm gonna pull just enough wire through that I'm able to go directly to this next stud. And remember, we've got a staple within 12 inches here. I'm also gonna leave an excessive amount in this box. That way we've got enough wire there for makeup later. It's always better to have extra wire in a box than not enough. So once we've got enough wire at our receptacle location, we can actually install it in the box. And if we look in the back, there's actually two knockout points in this box. We're gonna use this farther wire entrance point. That way we're away from the stud. That way when the drywallers install the sheetrock, if a screw goes in sideways, there's a lot less chance that that screw is gonna catch that wire way back here in the back of the box. Now that wouldn't be an issue here on the face, but if we imagine the back side of this wall getting sheetrock as well, that screw could absolutely nick a wire that close to the stud. When we staple this wire up this stud here, we're actually gonna be in the middle of the stud. To knock these wire entrances apart, I like using needle nose pliers. In this case, because there's a wall behind this wall, I'm actually gonna use a screwdriver, and I'm just gonna reach in there, and I'm gonna pop this piece of plastic up, just like that. And now with that entrance open, we can actually install our wire up inside of it. And remember, it's okay to have an excessive amount at the receptacle location at this time. So here's what it looks like overall so far. We've got our wire ran through the wall to our receptacle location. We've got an excessive amount of wire outside of it, and now we can actually go to the stapling step where we mount this wire to the stud. That way we're strapped code legal. So the National Electric Code actually requires us to staple, like I said, within 12 inches. So I am going to take one of these staples here, and I'm going to install it within 12 inches of the box, and I'm gonna take care to make sure we are approximately in the middle of this stud. And there we go, this is properly strapped. Now the code actually says after the box, we need to strap or support the wire every 48 inches. Well, because these studs are 16 inches on center and the wire is actually supported inside these stud holes, that's actually considered our support. So we actually don't need to do any strapping here horizontally because the studs themselves actually are counted as support. Now over here at the electrical panel, we need to get this wire up inside this panel. It's very important to note that before working in any electrical panel that you shut the main circuit breaker off. Now if we actually look up here inside the electrical panel's base, there's actually these spots where they've got pre-punched for us to come in with a cable. Now because this is a used panel, there's actually already a spot here to come in with a cable. But for the sake of this video, let's knock out this front knockout right here in the panel, and we'll actually come in right here. Again, the way I like to do that is with needle nose pliers. So what I'm gonna do is I'm gonna line up my pliers with that knockout, and I'm just gonna smack it up in there, and it'll actually break that free. So here we go. And with it up at an angle like that, now I can open up my needle nose, grab this knockout, twist it back and forth a couple times, and that piece actually breaks off cleanly. Now, we cannot just shove the wire up through this hole. We need to install some sort of connector that's actually going to protect that wire going through this. In this case, I'm gonna use these little plastic connectors, and all these do is they just snap right up inside that knockout that we just broke out. So we can take this little connector and we can line it up with our hole and simply pop it up into place. So with the connector installed and the wire to the stud pocket where the panel is, now we can actually get the wire up into the panel. We have to follow the same strapping requirements as we did with our box. We have to strap within 12 inches of the electrical panel. The amount of wire that we actually need in this panel is basically enough that we can get up into the panel and we can go anywhere in the panel. It's always better to leave excess wire at your electrical panel than not enough. Typically what I like to do is if I'm coming into this corner right here, I like to bring the wire up in the box and leave enough wire in there to loop all the way up and to the other opposite corner of the box. That way I know I've got plenty of wire in there because we actually need to cut this NM open, and those 3 wires in this sheath actually need to go to different locations within this panel. So I'm gonna go ahead and cut the wire over here, and that will ensure I've got plenty of length available within this panel. Now we can push our wire up through our connector. We're gonna pull it just tight enough that there's a tiny bit of slack on this wire so we can put our NEC required staple within 12 inches of the panel. Then we can go ahead and install our staple and our excess wire. For right now, we're just gonna tuck up inside the electrical panel. It's at this point that we can strip out our box wires as well. The easiest way I've found to strip out NM is just simply using a razor knife. Now, we're not gonna be sawing into this. We don't want to nick the wires inside of the outer sheath. All we want to do is remove this white portion. So what we're gonna do is we're lightly gonna score the wire way back here. We still have to have some of that white insulation as it comes into the box. And all I'm doing is just running the knife very lightly over that insulation. I'm hardly even cutting into it. And then once it's scored, all we need to do is give the sheath a good tug and it'll actually pull right out. If there's any of this paper left on the wire, you can go ahead and rip that off. Otherwise, your ground will have this paper piece around it as well, and you can just peel that back and rip it off all the way back where you scored it. And there's what it looks like inside the box. Notice there is just enough of that insulation on there to still be visible within the box. Now with these wires stripped out, we're gonna do something a little different than you were probably thinking. We're actually going to fold them up and we're actually gonna shove them all the way into the back of the box. You're probably wondering, that's not how you install a receptacle. It's at this point in the project that we need what's called a rough-in inspection. Once we've done everything that can be done inside the walls, we actually need to call the inspector in and they need to take a look at that wire we just ran in the wall and make sure everything is stapled correctly and make sure there's no problems with the wire run. After the rough-in inspection has been passed, the wall finishers can actually come in and close the wall in. After the wall is closed in, then we go back and then we actually finish the project up. So let's pretend our rough-in inspection has been passed, and let's pretend there is sheetrock on this wall now. So imagine, if you will, we can't see this wire anymore. We got a nice white wall here. So now we can come up to our outlet box and pull out our wires, assuming the sheetrockers didn't cut them with their rotozip. So we're gonna trim these wires back so there's at least 6 inches of free conductor. What that means is where it leaves the raceway, now that's the cable we installed, we've gotta have at least 6 inches of wire. So that would be about 4 inches of wire sticking out of the box. And I'm gonna go ahead and cut those wires right there. So here's our receptacle that we're going to install right here. This is a 15 amp duplex receptacle. The black wire, our hot wire, is going to land on the gold colored screws, these brass colored screws. The white wire, which is our neutral, is going to land on these silver colored screws. And then finally this bare copper wire is our ground, and that is going to land on this green colored screw right here. So let's take this black wire for instance. What we're gonna do is we're gonna take a good pair of strippers and we're gonna come back just over 1/2 inch. And we're gonna find the wire marking size listed on the wire strippers, and that's the one that we're gonna use. That's the hole size that we're gonna use. In this case, we've got 14 gauge solid wire, and we're gonna find 14 gauge, which is right there. So that is the hole that I'm gonna use to strip out this wire. So if we put this in like so, remember we wanna leave just over 1/2 inch, and then we squeeze, which cuts the outside of the insulation, and then we pull the wire through, and see how it pulls the insulation right off the end of that conductor? We're gonna do the exact same for this white wire, just over 1/2 inch. And because the ground doesn't have any insulation on it to begin with, we don't have to do anything extra to it. Now, in order to actually install these wires on this receptacle, we're gonna need to put little loops on the end of these wires so they can wrap around these screws. Now, for those astute electricians out there, you might know that these little holes in the back of the receptacle are actually pressure connectors built right into the receptacle. So you could actually just poke the wire into that little hole, and there's a little piece in there that will grip the wire and make the connection for you. That way you don't have to make any loops and you don't have to tighten any screws down. I actually do not like that method, and the reason for that is it's very difficult to remove those wires when this receptacle fails. And usually the reason the receptacle fails is because that connection point has melted. So now your wire is ruined and your receptacle is ruined. It makes it a lot more difficult to actually replace this receptacle in the future if it needs to be replaced. So I actually prefer to use the screw terminals. That way everything is removable and we're able to service this receptacle should it ever need to be replaced. This is actually another reason I like the needle nose pliers, because in order to put the loop on the end of this wire, all you have to do is grab it with the needle nose and twist it into a little hook shape. And there we go. That's all we need to wrap around these terminals. If you've got a wire strippers like this, that's actually the purpose of these little holes right here. These are for making loops. Put it in and you can use it to make your loop, just like that. Like I said, I very much prefer the needle nose pliers method. For me, it gives a lot more control. So there we go. We've got loops on all of our conductors. Now we can actually start terminating the wires on this receptacle. We have to be very careful that we actually loop the wire around the screw the direction the screw tightens. What do I mean by that? So here's our gold colored screws. Let's land our hot wire first. So what we're gonna do is we're gonna loop this black wire around that screw terminal like so. As I tighten this screw, the screw is actually going to be grabbing the wire and pulling it in the direction that the wire is entering that termination from. If we were to install it backwards like this, of course this is not where this wire lands, but if we were to put that loop on here this direction, as the screw tightens clockwise, it's actually going to pull this piece of the loop out of that termination, and it's actually going to make that wire want to leave that termination and not stay in it. Now we can flip the receptacle over and we can land the neutral on the silver colored screw. And it's very important to check your connection that none of your insulation is actually under the screw. You should have absolutely no insulation from that wire under your termination point whatsoever. It should just be pure copper under that termination. If you do have some insulation under your termination point, you need to redo that connection. And finally, we can terminate our ground screw. Same thing, we gotta make sure the wire is entering the termination the direction the screw turns in. And as we can see, as I tighten this screw down, it actually pulls more of the wire into the termination and doesn't push any of it out. Now this receptacle is fully terminated and we can actually install the receptacle in the box. So in order to shove all this in the box, all we need to do is fold the wire so we're able to push it all the way in. These two screws right here correspond with these two holes on the box. And we just simply tighten these down. Yes, you could use a manual screwdriver, or if using a drill is an option, use a drill. Don't over tighten these though. I just went down almost all the way. There's still enough slack though that I can move this receptacle around. Once I get to this point, I'll actually visually make sure that the screw is center on the receptacle mounting point, and then I'll go ahead and tighten it down. Same on the bottom, make sure that screw is centered on the strap. And there we go. This receptacle is now mounted solidly in place and those screws are not over tightened. If you over tighten those screws, you can strip out the box and you can wreck the head. Now that the receptacle is installed in the box and it's all wired, we can actually install the receptacle cover. These usually come in these little plastic bags. It's easy just to grab a corner and tear it like so. Then you can remove the plastic very easily, and here is your receptacle cover. This particular brand is pretty cool. It comes with this little screw capture piece right here. Sometimes those screws are actually floating around inside that packaging and you have to hunt for it. To install this, all we have to do is tighten that screw into that hole right between the two parts of the receptacle. So the plate just goes on like this, and a flat screwdriver to tighten it down. Definitely do not use a drill for this step, as you could inadvertently break this cover. This is just snug, just enough that this isn't wanting to move. Also notice that I intentionally left the screw straight up and down. Yes, I could tighten that a little bit more, and maybe it's a tiny bit more secure, but for aesthetic purposes, a good electrician is always going to make sure they have a consistent location for their screws. I know it sounds insane, but I guarantee if you leave one of your screws at a 45-degree angle, somebody's probably going to yell at you. It's a pride thing. It's paying attention to those little details and making sure that everything is consistent. So it's been baked into my brain that every time I install a receptacle, I put my screws up and down. There are other electricians out there that like putting their screws horizontally, and that's totally fine. So long as you stay consistent with what you do, it puts that little cherry on top of your project. So now with the receptacle done, we can actually move on to the panel, land this in there, and actually heat this circuit up and do a test. Here's our wire coming in, and remember, we left a big loop in here just so we knew we had enough wire to get to anywhere we needed to within this panel. So we're gonna go ahead and pull this out, and we're gonna strip this cable out the same way that we stripped out that NM in the box. We're gonna leave just a hair of insulation entering the box, but otherwise we're gonna strip out all of this wire here, and it works the same way. All we're gonna do is we're gonna take a razor blade knife, score it just a little bit. Remember, we're not going to be nicking the wires inside of the sheath. We're just wanting to score the outside of the NM. Then all we gotta do is take a good grip on it and pull, and it actually just pulls right off. Same thing on this ground. We've actually got this paper covering on it. We're just gonna go ahead and remove all of that. This electrical panel is mocked up as a main service. Now what that means is we're actually gonna be able to land the neutral and the ground wire on the same bus bar. For technical reasons that we're gonna get into in a future video, in main services, we can actually do that. We're allowed to share the neutral and the ground bar. But if this was mocked up as a sub panel, then we would have to keep the neutral and the ground separate. Again, that's a little bit more of a complicated topic that we'll discuss further in a future video. What we're gonna do is we're gonna shove this wire in the back of the panel the best we can and route it so the cables will look nice and neat within that panel. We don't want wires just kind of drooping across the panel. We want everything to look nice and neat, at least as nice and neat as we possibly can. With this bent into shape, I'm gonna aim for these bottom two screws right here. So let's do the neutral down here towards the bottom, and we'll do the ground right above it. So this neutral needs to be approximately that long to land on that screw. So we're just gonna go ahead and cut it off about right there. You're gonna want to strip out just enough that we're able to go all the way through that terminal strip and have solid copper connection the whole way through. So with the neutral cut and stripped, we're able to put it right in the terminal spot that we were hoping to hit, and we're just gonna go ahead and tighten this screw down, and the neutral connection is done. Now let's go ahead and land the ground wire. So same thing, we're gonna kind of hold it roughly in place, find where we're going, and then just put our finger right where it would end up on the back side of that terminal strip. So I'm gonna cut it right about where the end of my thumb is. So I'm gonna use my other thumb to mark that spot. Now we can grab our cutters, cut it to length, then we can put it into our targeted location and tighten the screw down. And there we go. That is the neutral and the ground complete. And remember, because this is a main service panel, we're allowed to land the ground and the neutral on the neutral bus bar. I went ahead and removed the two circuit breakers that I had in this panel. Let's go ahead and figure out a better spot for this particular circuit. Now, if this was an actual job and we had a print, we would actually want to make sure we land this circuit where the print tells us to. So we'd have to make sure we chose the right spot for this particular breaker. In this case, we don't have a print, so we're just going to choose a spot. Now, it's going to be really convenient to install the circuit breaker on this side of the panel, simply because the wire enters that side of the panel. But remember, we left this wire long enough that if we had to, we could easily loop it up over top and install it in a breaker in this position. Or we could even install the wire on the bottom here and go this way and install it up in this location. It doesn't matter. We left ourselves options. That's why you always leave long wire in your electrical panel. In this case, because we don't have a print and we're kind of installing this where we want, I'm gonna go ahead and install this breaker right up here in this corner. Now, once we install the breaker, we're gonna land that black wire on this screw right here. So if you take a look, right there's that yellow square D symbol. Right underneath it is the screw that wire is actually gonna land on. So I'm gonna go ahead and snap this in to the panel. Snaps in on the one side and then it snaps in on the bus bar. So there's actually two snap pieces that hold that breaker in place. They also make breakers that bolt in to the main bus bars. Now the last real major step is to simply bring this black wire, kind of tuck it into place where we want it out of the way. Again, we want to try to make things look nice and neat. We want to make things look grouped together and not have wires going across the panel. So holding this wire in place, right about there is where we're gonna wanna cut it. That looks like it's gonna work right there. Now we're gonna strip out about a 1/2 inch, just a little bit less than we would normally strip out with the terminals on the receptacle, because we don't need to twist anything. And we just slide it in there and we snug that screw down. We don't wanna go hog wild on this screw, or you will break through the plastic on the breaker and potentially ruin your breaker. And there we go, that's it. We're ready to fire this up and test our receptacle. But before we do, we have to install our panel cover. Unfortunately, my panel is used, so I've got a couple extra knockouts here for the breakers. So what I'm gonna go ahead and do is just install a couple extra breakers in the panel just to cover up those spots. I don't have any breaker blanks handy. So with the panel cover on, let's fire this up. Now, because my demonstration setup here is a little unique, I gotta turn my transformer on here, and now we should be able to fire up this panel. So we flip the main circuit breaker, and then we flip our circuit that we just installed. Our receptacle should be live now. Now, before we call this installation done, let's check it with something like this. This is a receptacle tester, and these little lights on the front are gonna light up in a pattern that tells us if we've got a correct installation or if we've made a mistake and something is backwards. So let's go plug this into the receptacle and see if it works. So we can take our plug tester and plug it right into our receptacle. In this case, you can see we get 2 orange lights. If we look at the legend on the front of the unit, it says 2 orange lights is correct. So it looks like everything's wired correct. We can call this job finished. As a new apprentice, you might not handle every step of this process. You'll probably do one of them over and over. Maybe pulling home runs to every room in an apartment, maybe going around stapling cables that's already been pulled, or maybe coming in after the rough-in inspection to install devices and cover plates. If you made it this far and you enjoyed the video, consider leaving a like, a comment, and even a subscription if I've earned it. Thanks for watching, guys. I'll see you on the next one. Bye.